Chapter 12, Section 5 is about circles in the coordinate plane. So here we have a coordinate plane here with an x and y axis and a circle. And we know that the circle is determined by its radius. So the radius is from the center to the outside of the circle. So here we're going to know that our circle, the center is the origin, which has the coordinates 0, 0. And then we want to find, we want to use this distance p, which we're going to just call xy because we want to find out what the general equation for this circle will be with a radius of r. So we use the distance formula to do this. We have x, which is just what we have for our x coordinate here, minus 0, which is our x coordinate of the origin, and then y minus our y coordinate of the origin, which is 0. So since the center is 0, 0, we have this equation, which we can then simplify and have x squared plus y squared equals r. But if we want to make this, we don't want this square root anymore, we know we can just square this, square both sides, and we get that x squared plus y squared equals r squared. So this is the equation of a circle when it's centered at the origin. And so x and y will be the points that will be represented by the point that is on the circle, such as this one. P is x and y. So if you know this point, then if it says that you have a circle centered at the origin, and then a point on the circle that is, let's say, 3, 4, then you would plug it into here. 3 squared plus 4 squared equals r squared, and that would give you the radius. That would be like they asked you for the radius. But then you could have a circle where it's not centered on the origin. So here we have a center of A, B, and then the point on the circle P is Q, or X, Y. Our center is Q. So the point on the circle is x, y. So if we want to find the length of PQ, which is our radius, we have the square root of x minus a, because instead of 0 this time we have our x coordinate of the center is a. So we have x minus a squared plus y minus b squared. And that equals our radius, which is this length here. So we can get rid of this square root sign by squaring both sides. So we get r squared over here, and then this square root, since we squared it, it's just whatever's inside the square root here. So we have x minus a squared plus y minus b squared. So this a and b represent our center here. Q would be our center. So if they gave us an equation, which is what the next example is, then we would know that A and B are our center, and it's always minus. So we'll see in the next example what we do then. So that's the general equation of a circle, which when its center is not at 0, 0, which is the origin. So if it's just at any center, A, B, and it would give you one, either the center here would give you that. So this is the example I was talking about. What is the center of the circle described by x minus 2 squared plus y plus 4 squared? So we need to make sure we know that this is going to be a positive because it's always in the actual equation we use a minus here. So the what we get here is x minus 2. That's going to translate to a positive 2 here. But since this is y plus 4, in the equation up here, it meant that we put in y minus a negative 4, so our coordinate in the center is going to be negative here. So then it tells us, and it also asks, so it says it's equals r squared, which is part of our equation, that you need to have this memorized. It's not so bad if you think about it in terms of the distance formula. But you are going to need to know that it's minus here, and that it's r squared. It equals r squared. So here it equals 16, so that's r squared, so our radius is going to be 4. So here it asks us to write the equation of a circle centered at 6, 3, and it has a radius of 6. So we're going to leave our x and y because it tells us we don't have that there, that it doesn't tell us that. It only tells us the center. So we have x minus 6. Make sure it's minus here because this is just a 6. So x minus 6, and then we're adding y this is x minus 6 squared, and then we're adding y minus 3 squared. And then it equals our r squared. So our radius is 6, so it would be 36 here. So when we're thinking about the equation, it's when we're given the center, we're going to use this form and then just plug in the center right here. Now if this was a negative 3, we'd have y minus a negative 3, so then we'd have y plus 3 squared. Okay, let's look at a few more examples. So it asks us, what's the radius, and write the equation for the circle centered at the origin. So the origin, we know then our center is 0. And then it contains the point 35. So this is our P. When we went back to this picture here at the top, this is our P. It's the point on the circle. So it contains that point. The circle contains that point. So first, we need to know what the radius is. So we're going to have our radius equals the square root of 3, which is our x, because it contains this point, minus 0, because then we have our origin. We always have the center second here. So we have the origin is our center, and then that squared plus 5 minus 0 squared, because 5 is our y coordinate here. So then we get 3 squared plus 5 squared, we get the square root of 34. So that is going to be our radius. The radius is the square root of 34. So then when we put it into our equation, we go back to the equation of a circle with the center at the origin here. We can use that and just have x squared plus y squared equals r squared. But then when we square r here, we get the square root of 34, and that is squared, so we just get 34. So this would be our equation for the circle. So it also asks to write the equation of the circle. And that is when our center is at the origin. Here we would need to sketch the graph of the equation, this. So here we know that since this is a positive, that means we are subtracting a negative 4. So our x coordinate here, it writes it up here for us, x minus negative 4. So our x coordinate for the center is going to be negative 4. So we need to go over negative 4 on the x-axis. And then it's y minus 3. So this is our positive 3 as our y coordinate. So we have xy is, for our center, is negative 4, 3. Then in order to find the radius, we could do it a few different ways, but here it's really easy. When it's 25 here, so we just square root that because it's r squared, and then we get that the radius is 5, so we can just count up 5 over here, over 5 here, down 5 here, and then this way 5 to the left. So then we connect all those points in a circle, and if we were to connect this to any other point, this length here, the radius will always be 5. So you would need to use a compass to do this. So if we were given the end points of the diameter are 3, 0, and 7, 6, we need to write an equation of the circle. So since we have a diameter, we're going to go back to what we know about finding the midpoint, because the midpoint of the diameter will be our center. So we know that the midpoint is x1 plus x2 divided by 2, and then y1 plus y2 divided by 2. So then we use our a and b, which are the end points of the diameter. So we have the x3 plus 7 here, and then 0 plus 6. So when we get 10 divided by 2, so that's 5. And then we get 0 plus 6 is 6 over 2 is 3. So our center we know is 5, 3. So then we're going to use this formula that we know. We can go straight to this if we would like. We just don't know our radius. So we need to, over here, find the radius using the distance formula. So we have the radius equal to the square root of, and then we need to use our center as one of the points, and then one of these endpoints, because we know that the diameter has endpoints that are actually on the circle. So we are using one of these points that is actually on the circle, and then the center. So we have 5 minus 3, because we are going to use this first point. We could use either one and we would get the same answer, but we have 5 minus 3. squared, and then 3 minus 0 squared. So we get 2 squared plus 3 squared. We end up with our radius is the square root of 13. So once we have that, we can use this. So since our center was 5, 3, we have x minus 5 and then y minus 3, each squared, and then equals r squared. So we plug in what we got for r using the distance formula. And when we square the square root of 13, we just get 13. So our final equation that we would need for the equation of the circle is x minus 5 squared plus y minus 3 squared equals 13. So our big takeaways from this section are knowing where our circle is centered. If it's centered at the origin, then our equation for the circle is just going to be x squared plus y squared equals r squared. And r is our radius. We were trying to find, because each circle is determined by its radius, because that is the distance that it's from its center out to its points. So we would need to know information about its radius to find out its equation. So we have x squared plus y squared equals r squared when it's centered at the origin. But when it's centered at any point, we can call it AB. And then we use the same exact idea that we did before, and we just need to make sure that instead of subtracting 0 here and 0 here, we're subtracting the coordinates of the actual center. So we have minus a and minus b, so we need to make sure that we remember that it's x minus a and y minus b, because when we start to see something like y plus 4, we need to recognize that it's y minus a negative 4, so when we're asked for the center, we know that that center is at a negative y value. Hopefully this helped. Let me know if you have any questions and bring them into class. Thanks.